This is the Concept 18 quiz review for properties of exponents. So in part A, simplify each expression. Make sure you're careful about using a calculator, because on some of these, if you use a calculator, you're going to get a decimal out of your calculator, and decimal answers are not going to be accepted. So on number 1, order of operations tells us we need to do the exponent first. Any number to the power of 0 is equal to 1, and then multiplication is next. So 53 times 1 equals 53. On number 2, again, order of operation tells us to do the exponent first. When we have a negative exponent, the rule is that we're going to take the reciprocal of the base, so that would be 1/5, and change the exponent to a positive. So that's 1 over 5 squared, and then we're going to multiply that by 125. So that would be 125 times 1 over 25. 125 divided by 25 is 5. On number 3, we have 5th root of negative 243 to the 3rd power. So 5th root of negative 243, in other words, what number can you raise to the 5th power to get 243? If you're unsure, you can always use a calculator to guess and check to figure out what that number is. So, for example, if you thought the answer was 4, you can check whether 4 to the 5th power is equal to 243. So we can see here that's too big. We can also see that it's a negative, so we need a number to the 5th power that will give us negative 243. So I'm going to guess again. So I'm going to type in 3, and I'm going to make it a negative 3 to the 5th power, and that works. Okay, so the 5th root of negative 243 is negative 3, but then I'm cubing that answer, so negative 3 cubed, or in other words, negative 3 times negative 3 times negative 3 gives us negative 27. Be careful with the negatives, because that's going to make a difference in this case. On part B, circle all of the expressions that are not equivalent to this expression. So one thing you can do to help out is simplify this as much as you can. 35 will be the numerator of my fractional exponent, and 14 will be the denominator. That can also be rewritten as x to the, I'm going to reduce this, so 35 over 14 is equivalent to 5 over 2. And this can also be rewritten back in radical form, square root of x to the 5th power. So let's go ahead and look at the options here. Circle the ones that are not equivalent to this. X to the 14 over 35, that exponent doesn't match this, so this is not equivalent. X to the 5/2, that was one of the expressions that we got when we were rewriting this, so this is equivalent. Square root of x to the 5th. Only difference here is it doesn't have the 2, but square root means the same as a 2 in the root spot. So this is equivalent. I'm going to cross that out. This is x to the 35 times 1/14. Here we have power to another power, so we need to multiply these exponents. If we multiply them, that's actually 35 over 14, which matches this. So this is equivalent. And then here we have x to the 5th to the 1/2. So multiplying exponents, we get x to the 5/2, which is equivalent. So the only one that's not equivalent is number 1. Part C, we're using property of exponents to simplify this expression. So this entire expression is being squared. So 4 gets squared. A to the negative 3 times 2 is negative 6. B to the 3 times 2 is 6. And then on the denominator we have all of these. Now we can look to see if anything can be reduced. So 16 divided by 8 is 2. For all of the negative exponents, I'm going to move the expression to the other side of the fraction. So a to the negative 6 gets moved and becomes a positive 6. b to the 6th stays where it is since it's a positive exponent. A to the negative 2 is going to move to the top and become a positive 2. b to the negative third is going to move and become a positive 3. Alright, so we have a 2. B to the 6th times b to the 3rd is b to the 9th, because we're going to add those exponents. And then we have a to the 6th on the bottom, a squared on the top. 6 minus 2 is 4, so a to the 4th in the denominator. Alright, the last two problems on here are solving equations. So on part 1 we have a power equation. There's a couple ways you can solve this. One way to do it is to raise each side of this equation to the reciprocal of this exponent. So that would be 3 over 2 on both sides. The reason we're doing that is if we multiply 2/3 times 3/2, that's an exponent of 1. So x to the first power equals 49 to the 3/2, which if you change to radical form is the square root of 49 cubed. So 7 to the third power, which is 243. Another way you could do this problem is to start by changing it to radical form. So in the beginning here, if we change this to cube root of x squared equals 49, then you're looking at this equation and thinking about, well, what value can we square to get 49? That would tell us that the cube root of x should be equal to 7. And then if you cube both sides, then you end up getting the same answer, 243. Alright, number 2 is an exponential equation with the bases having different values. So the only way to solve this at this point is to change the base to the same number on both sides. The only base that can be used on both sides is a 2. 2 to the 3rd is 8. 2 to the 5th is 32. So here I have an 8 rewritten as 2 cubed, but I still have the original exponent equals 32 I rewrote as 2 to the 5th, and I still have my original exponent. So I'm going to write the original exponent in parentheses because we need to use distributive property. Now that both sides have the same base, I know that this exponent on the left has to be equal to this exponent on the right. So I'm going to drop the bases and rewrite 3 quantity 2x plus 3 must be equal to 5 times the quantity x plus 3, and then we're solving that equation. So 6x plus 9 equals 5x plus 15, x equals 6. A good thing to do also when you're done is take that solution, plug it back in, and verify that 8 to the 2 times 6 plus 3 is actually equal to 32 to the 6 plus 3.